So welcome to the beginning of this tutorial, and I'm going to show you what we're going to build today so that you get a flavor of what you're going to be able to get to at the end of this tutorial. Here we go. By the end of this tutorial, you will have what I call an endless survival beat 'em up game. You play as this pirate, and then you will have continuous waves of skeleton enemies that will come, and it'll get increasingly more difficult as more and more of them turn up over time. And while this game may seem quite simple, the key thing here is to enable you to understand the fundamentals, such as loading in game art, how to implement collision detection, how to implement movement. Everything that you learn today will be applicable regardless of what games you're trying to build, whether it's a top-down game, whether it's an isometric game, whether it's an arcade game, because all of the concepts that you learn today will be applicable. And you will be building this game from scratch, from this starting folder of files, and I will take you prompt by prompt all the way from start to finish. And the goal here is to help you build the muscle memory to be able to build games such as this. All right, before we jump in, I've made all of the files that you need for free as part of my Insiders Club. Link is in the description below, and you'll have everything you need to follow along with today's tutorial. And if you'd like to dive deeper with even more resources on AI-powered game development, you can check out gamedev.com. Within it, you'll find a full written and broken down tutorial of what we're going to go through today. It also includes a lot of game development-specific agent skills and the full source code of all of my other projects that I've been working on throughout this channel. There's also a private, exclusive Discord community where fellow game development vibe coders hang out, sharing tips and tricks with one another to help each other along on their journey. So without further ado, let's get back into today's tutorial. So once you've got your project onto your computer, it's time to get going. I'm just going to walk you through what's inside the folder so that you know where we're starting off from. A lot of these files that you see here are just called boilerplate. It's just the basic things that are required for the game to get up and running so that you can play it on your computer in your browser. There are several things that I would like to call your attention to, and let's just start off with what's inside this public folder. Now, the public folder is where we will store all of our game assets. And you will see that there are already two folders here. One is called the pirate, and one is called skeleton. And within it, it already contains all of the assets that you'll be using within your game. In the animations folder, you have the attack, death, hurt, idle, jump, and walk. And within these are what you call sprite sheets. A sprite sheet is a combination of all the individual frames such that your character can animate within the game. So if you look at this dev sprite sheet, if you play this in sequence, you will get an animation. You can just look at the preview.gif file over here. When it's stitched together, you get a complete animation. The folders that you have here has all the sprite sheets for the skeleton as well as the pirate character. So you really have everything that you need to go ahead and build this game that you see over here. So the other thing to call attention to is that you will see that you have a .agents and a .clock folder. These two folders contain things called skills, and you will see that the skills that are present already are the phaser and phaser 4 game dev skills. So in today's tutorial, we'll be building this 2D game using the phaser game engine. And that's the reason why we have loaded in these phaser skills. It's basically an instruction set as well as a knowledge base that gives your AI superpowers in a related domain. So in this case, it's going to be an expert in building games using the phaser game engine. Because the skills are provided for both Claude Code and any other AI agents, you can use Cursor, Claude Code, OpenCode, Zencode, or the Codex App. I highly recommend the Codex App because Codex App does provide a lot of additional functionality as part of your ChatGPT subscription. For today's tutorial, I'll be using the Codex App from OpenAI. In the Codex App, you're going to go to File. I save this as VGD Pirate Survival Beat 'em Up. So I'm going to open this right over here. And once you've loaded it up, you will see that this is the folder that we're going to be in. You want to be working locally and you want to be in the Start branch. Okay? All right, and in this case, if you know what you're doing, you can go to full access, which means that Codex will not prompt you for any permissions, and it should be fairly safe when you're doing this tutorial. If you want to be more cautious, you can do auto review, which means that Codex will only ask you when it thinks that it's doing something more dangerous. At the time of this tutorial, I would suggest you use 5.5, and you can switch between medium or high. If you have a higher tier of the Codex or ChatGPT subscription, like Pro, you can go to fast, which will make things a lot quicker. If you have a lower subscription, and you can just use medium, but if you are on a higher tier subscription, you can go ahead with using high. So as you can see in this case, I'll be using high and fast. Feel free to stay on the standard speed in order to proceed. Okay. So the first thing that we're going to do is run this project. This will look like a magic command if you've never used it before, but let's just go ahead and do it. If you go over here and click toggle terminal, or you can do Command J, this will bring up this little console below over here. Don't worry about it. All you want to do is you want to do npm install. Okay, this will just install all of the dependencies to run your game. The next thing you want to do is to run npm run dev. Okay, and you'll see something like this pop up. You will say it's ready, and then you will have something called local and network. What you want to do now is just open this up in your browser. You can hold on the command button or the control if you're on Windows and then click on this button. And this will now open up the game within this window that you see over here. Now, the problem with this is that while it's great that it shows up over here, it will appear quite small, okay? Unless you click on this play button over here. And then now once you're within it, you can do up and down. You can go to settings, you can mute, and then you can go back to the main menu. And then the other thing that you can do is that you can go to sandbox and you will see that this will be what we start with. It's just a very simple square that's walking around that allows you to use the arrow keys to walk around on the screen. By the end of today's tutorial, you will get from this very simple looking sandbox, which is just a starting point, to having this fully fledged complete game that you see over here and that we were discussing at the beginning of the video. Now, one thing that I'll encourage you to do is because this screen is embedded within your window, and if you're working on a laptop and a small screen like me, what you can do is that instead of just clicking on this here, you can just copy this location and then just copy and paste this location onto your browser. With you have a much larger screen version of what you see over here rather than having this collapse within this window over here. And the reason why you want to do this is that when you're in this full screen debug mode, you have this console on the right, which will help you to perform troubleshooting steps in the event that you hit any issues. So for example, as I'm moving around with this character that you see over here, you will see that the input on the right, as well as the location of the pointer, is updating in real time. This is part of today's tutorial. You will see that having debug visualizations such as this will help you to troubleshoot if you encounter any errors along the way. All right, once you're able to get to this stage, you are all set because the game is running, your project is loaded up in Codex, and you have all the files that we discussed over here. So you will be ready to go ahead and begin implementing this game. All right, so let's get started. So we're going to be in the Codex app, and you want to make sure that you've opened up your project folder. In this case, it's VGD Pirate Survival Beat 'em Up game. Beat 'em up. Double check that this is the case. And then you want to be working locally. If you clone this from GitHub, you should be on the start branch. Don't worry too much about this because we will not be doing any version control as part of today's tutorial. If you know about Git, you will know that this is the branch that is the beginning of the project. The first thing that we're going to do is, if you recall, we have this nice background art that you see over here. And I thought that the first thing that we'll like to do is to show you how I actually got hold of this background. And this is the prompt that we're going to use today. So I'm going to look through this. I'm going to take you through this step by step. All right. So the first thing it's going to do is that I'm going to ask it to look at all the images that we already have. And if you recall, we have 2 folders of animation sprite sheets, including ones for the pirate, across all of the different states that we have. And then we also have one more for the skeleton character. So what we're saying is that study these assets because this is the style of the game that I'm trying to create. I want it to create a single level with no scrolling using these 2 characters. And I want it to generate 4 candidates. Make sure that there is sufficient space to walk around both horizontally and vertically. And there needs to be a limit to the vertical range because this is going to be a backdrop. Now, one thing I'm going to do here is that you can see that I'm saying I want to generate these 40 candidates using image gen. If I click over here, I'm going to use the image generation skill that's built into Codex and that piggybacks off your ChatGPT subscription. So this allows you to generate images for your game without needing any additional subscription. Finally, I'm going to say place these into public assets backgrounds and use parallel subagents. All right, so now I'm going to kick this off and I'm going to explain to you what I'm trying to do. In the original tutorial related to this project, I created 4 different backgrounds before I landed up on the final version that you see over here, which is like on the ship. I asked the AI to generate 4 different backgrounds and I got a pirate cove, one that's on the docks, one that's on the ship, and one that was in the ruins. The reason for this is that you want to have some room to experiment and to see what suits the style that you want. Now, if you look over here, Codex will look at the 2 images that you have within your project, okay? And it's able to look at these images. It's going to say, okay, I now understand what the style of game that you're going for, which is really useful, okay? If you remember, I said use parallel subagents. You have seen that these 4 background agents have spawned. And what's happening here is that you want 4 different backgrounds. Rather than doing it sequentially, you're telling Codex just spawn it in parallel so that you get all 4 backgrounds around the same time. This is a very powerful tool that you should be making use of when you're using something like Codex. All it takes is just a single line like this, and it automatically will spawn all the 4 parallel threads for you. As you can see here, these will now start to land and appear within the artifacts. This is the reason why I encourage people to use the Codex app as part of this tutorial, because not only does it work off your ChatGPT subscription, which you probably already have, but the overall user interface has gone through a lot of changes that's made vibe coding a lot easier. All right, we are landing with these 4 candidates, and so Codex should be wrapping up pretty soon. Because you are using the inbuilt image generation, Codex will actually store these images in a different part of your computer. So what it's going to do is do this final step that we said over here, which is put it into public assets backgrounds. It's already created a folder, and it's going to put the 4 backgrounds into this location. And yep, just as I said it, it's landed here. The reason why you want it to be put over here is because our game needs to be able to be self-contained and have access to all of these backgrounds so that we can load it in. And here he is, and it's completely done. It took about 7 minutes to get all of these images, and they're all great candidates for us to put into the game. So now that we have these 4 images, the next step is teach our game and the AI to load in the backgrounds as well as the 2 different characters. So the way that we go about teaching our AI as well as our game to know about these new assets is that we're going to do the following. Say, look at the assets that exist, and then an assets index.json that will serve as a canonical index to all available sprites in the game. This means taking into account single sprites like the backgrounds, as well as the sprite sheets used for the animations. Specifically, for the sprite sheets, we need frame size, number of frames, offsets, and any other metadata useful for integration into a phaser game. So I'm going to kick this off and explain what we're trying to do. But effectively, even though we have all our assets with the different backgrounds that we have in the game, our current game still doesn't know about them, right? Right now, all it has is this blue square moving around in a black screen, and it needs to load in these assets. What we're trying to do here is create something called an index or an asset index. And the goal here is to create a single file that will point to all of the different assets that are available for us to integrate into this game. And the reason why you want to have a single file is so that anytime that the AI needs to look up a particular sprite sheet or character or background, it doesn't need to list all the files within the folder anymore. All it needs to do is just check this single file, and it will be able to find it immediately. This will help save on your usage and your tokens. The second reason for having a single file serving as an index is that if you're adding in new animations or backgrounds or sprites, you can tell the AI to update the index file, and the game will know where and when to pick things up. And this is good practice. If you watch any of my other videos, you will know that this is something that I do regardless of any game that I'm building, whether it's a 2D game, whether it's a 3D game, I always have an index.json file. And so just jumping back here, it says it has created the index.json. Click it over here and you will be able to see the result. Now let me just walk you through what's been added over here. So if you look, the index.json now has a couple of really important things to note. So it tells you when it was generated, where the assets are stored, and most importantly, now it has listed that it has 4 backgrounds and a lot of information related to what these backgrounds are. And then the other thing that it has is that it has every single animation that you see over here. And the best way to show this to you is to actually take up one, such as the hurt animation. Okay, I'm just going to pop this to the side and then keep the index.json on the left. So now if we look for hurt, you will see here it's telling you that this entire sheet is 1280 by 512. There are 5 columns and 2 rows. There are 6 frames, so 1, 2, 3, 4, 5, 6. And then it has information on the frame rate that you want to run, as well as the different anchor points for each of these. The anchor points are really important for it to be able to play animations such that they're not all jumping around. You don't really have to go into too much detail about what this is. This is really meant for the AI to be able to understand what assets you have. Now that we've got all of our assets and we've got this index.json, it is time to move on to the fun part where we actually start to integrate all of these assets into a playable game. So I'm going to use this prompt that you see over here. And there are 2 skills that we're going to make use of included in this project folder. Now, Phaser Game Dev is because we're using the Phaser game engine. So this contains a lot of information and knowledge about how to utilize it. And Phaser 4 is because it's the latest version of Phaser. And there's a couple of new things that we want to make use of so that the game runs really well. And so you can see here, we're going to integrate the pirate into the game. We will support WASD and arrow keys for movement. We will have Z for attack, and it should animate correctly. And over here, what we're going to do is that we're going to say, we want to use background 2 as our chosen background. All right, and then we're just going to kick this off. And you can see from my prompt, It doesn't take a lot at this point because it has already enough information about what it needs to do. It's going to be able to just take this very simple prompt and give you something that resembles a working game very quickly. All right. So you can see here, it's going to use both the phaser skills, right? Phaser 3 is driving the implementation, and phaser 4 will be used to standardize it and make use of some of the newer features. If you want to look at different skills that you have, you can go into plugins and then onto skills. You will see that Codex comes with several inbuilt skills like the image gen, which is the one that we were using. And because I've included additional skills as part of this project, you have the phaser game there as well as the phaser 4 one. All right, well, let's jump back into our game here. And you can see that it's looking at what we have in the game already. And if you recall, the game currently has just a single screen with the blue character moving around. This is called the sandbox scene. So the AI is now thinking, what should we do now? Should we create a new menu screen? Or should we just replace what's already there? And it's decided that it's just going to go ahead and replace what's already there. If you wanted it to create a new menu item, because of the boilerplate that we already have, you can simply say, I want a new screen, and it will do that and retain this sandbox over here. And there you have it. It's already started to integrate the character into the game. And let's just play around with this. WASD works, all right? So I can move up, left, down, and I can use the arrow keys as well. If I press Z, it does the attack. And this is looking great, right? Like already you have something that resembles a game. It's done a really good job of making sure that it doesn't step into the water, but you might notice that if it walks too far to the left, it might end up walking on some of the props over here, okay? And I'll just show you the reason why. You can see that there's this wall bounds that constrains where the character can walk. And you can see over here it's correct, but if we walk further to the left, you will notice that it's a little bit too far and we should be making this wall bounds a bit shorter. But more on that later. Now, if you're working in Codex, you will probably notice that sometimes it will launch a separate browser for you. And this is one of the cool things about using the Codex app, is that it has something called browser use built in. As you can see here, it's going to resize the browser, and then it's going to look at the files, and then it's going to try to take several snapshots of the game as it loads up the browser. The idea here is that it's trying to do an automated verification about whether its changes made sense. In some cases, you will need to say allow over here so that it's allowed to press keys for you, and you can see automatically pressed the sandbox button so that it could load up the game. And this is a really powerful tool. And you can see it's looking at what's on the page right now. I'm going to shift this side by side so you can see what's happening. Effectively, what it's done is that it took a snapshot and then it pressed a browser key. And then now it's trying to take another screenshot again. Okay. So what I'm going to do is that I'm going to steer this a little bit. I'm going to say, do not clear or delete any playwright screen so that I can keep track of our progress. Okay. And I'm just going to press enter here. And you can see this called steer. Okay, and this is a nice thing about Codex as well. You can either cue this message to happen at the end, or you can actually start to steer it. And as you can see here, I managed to steer it so that it doesn't delete the screenshots because I want to keep track of this as we go on through this tutorial. I'll leave every playwright screenshot in place because I managed to steer it, and so it didn't lose context of where it needed to be. And what I'm going to do now is allow for this chat so that it doesn't keep prompting me. Another thing that you can do is set this to auto review so that it will not keep prompting you whenever it needs approval for something like this, and only when it looks like it's doing something dangerous. If you jump into the game and allow it to continue its testing over here, you will see that everything is working as we expected it to do. So we are able to walk around, we're able to attack, and this is really starting to take shape. So what we're going to do next is that we're going to start to make this game a lot more interesting by integrating the enemy and have a bit of challenge into the game. Unfortunately, I recorded this bit and I accidentally killed the screen recording. So I lost the raw footage, but I'm just going to give an overview of what I did. The next thing that we want to do is to make this game more interesting by adding the skeleton character into the game as an enemy. Now let's add a skeleton enemy using the skeleton sprite. The enemy is slower than our character, but can attack our character. When it attacks, the hurt animation is to play. There is a knockback of the player in the direction of the hit, and the enemy needs to pause a while before continuing to chase the player. And let me explain to you what is going on here. So if you see this final version of the game, when the enemy attacks, you will see that the player gets hit backwards away from the enemy. And the enemy also doesn't give chase straight away. There's a bit of a pause. Now, what I'm trying to demonstrate to you here is that while vibe coding can get you very far, sometimes you find that it's quite difficult to explain the kind of effect that you're trying to get out for your game. But using terminology such as this, even things like sprite sheets and sprites, and in this case, using something like knockback, and also having some sense of how the game feel should be like, which is having this enemy pausing. These are things that are more important than understanding how to implement it because AI will handle that part for you. So the main thing when you're vibe coding games is that you want to be in a position where you can describe it in the best possible way for the AI to be able to go ahead and implement it. Let me just show you what the end result was at the end of this stage. So if we jump to the game now, you will see that the skeleton has been integrated correctly. The skeleton can hit the player, and there is the knockback as well. And you will see that there is always a brief pause before the skeleton starts chasing again. In the past, if you wanted to implement something like this, it would have taken you quite a while. This just took a single prompt, as long as you know the right kind of terms to use to get the effect that you want. Now you will see that there is a problem with this attack. While everything looks fine at first glance, there are several things that you will notice. So the first problem that you will notice is that even before the skeleton hits me, I'm really suffering from a damage, and that doesn't look right. Now the other thing is that I don't even need to be in the range of the weapon, but the player is also getting hit. These are bugs that completely break the immersion and fun of your game, and that's why it's important to learn how to troubleshoot this using debug. So what I'm going to do right now is I'm going to show you the reason why this is happening in this final game. I'm going to pause the game for a while so you can see on the visual bounds. So this is how the characters are placed within the world based on their 256 by 256 frames. But the main thing that you want to see are the hitboxes and the attack boxes. So the hitboxes just tells you where exactly the weapon needs to hit in order for it to register. And you can see it's not the entire frame, it's just the box. And this applies both for the skeleton as well as for the player. The other thing to highlight is that when we're walking, there are no attack boxes. It's only when the skeleton starts swinging that you see the yellow attack box, and only when I start attacking that my orange attack box comes out. This is what makes the game feel a lot better, because when all of these are in place correctly, it only registers the hit at the right frame, and this makes sure that the game doesn't feel broken, as we see over here. Okay, so what we're going to do now is add the debug drawing so that we can start to visualize what's going on. So for us to be able to visualize this, I'm going to use this prompt over here. I'm going to say it is worth being able to visualize the visual bounds, hitbox, and the attack boxes, which should be separate elements for each actor, the pirate and the skeleton. Add these debug bound toggles to the right-hand panel. So we're going to kick this off. And so what we have here, you can see that the bounds are now showing over here. And if we go into the game, I'm going to turn on the bounds so that we can actually visualize this. So immediately you can see several problems. So you can see immediately that the hitboxes for the character as well as the skeleton are not accurate. And secondly, the attack boxes of the character and the skeleton are way too big and are already appearing on the first frame. So if I resume this, watch this. The moment the skeleton swings back the weapon, it already registers as a hit, and that's not the feature that we want. Okay, so hopefully with these changes, you can understand the value of being able to see these debug bounds in the game. And as you can see here, Codex has taken a screenshot of the game just to make sure that the debug bounds are showing correctly. Okay, so now that we know what are the problems, let's try to fix this. So we're going to fix the first problem where the weapon is showing up all the time. So this is the prompt that I'm going to use. I'm going to say, looking at the sprite sheets, the extent of the weapon only happens in frame 4 for the pirate and the skeleton. So you can see 1, 2, 3, 4. Only at the 4th frame does the weapon actually stick out. Everything else is just like part of the winding up. And this is the same thing for the skeleton as well. And you can see over here, yep, only in the 4th frame. Okay, so we should reflect this, otherwise the player gets hit even in the wind up. Take this opportunity to do the same for the pirate and implement damaging the skeleton in a similar way with kickback. So if you recall, we actually have not implemented attack, so it's very one-sided right now. So the player can't attack the skeleton at all. So we're going to replicate the functionality that we see with the skeleton attacking the pirate to be able to walk the other way as well. So we're just going to kick this off. And the goal here is so that we'll be able to have much better hit detection and also the ability for us to hit the skeleton as well. Let's take a look at where it's gotten to right now. I'm going to pause the game for a while and take a look at all of these. So you can see that we have all of the attack boxes now. And this time, only when it's in frame 4 do you see that the yellow and orange attack boxes get highlighted, which means that only when that frame is playing does the hit register. And this is looking a lot better now. So when there's a wind up, I still have a chance to run away, but the problem still stands. So in terms of the timing of the frames, it still works, but the hitboxes are still not right. And the attack boxes are still not right in terms of size. So now let's fix the sizing of these hitboxes so that we at least have a chance to run away from the enemy. Otherwise, it makes it a lot difficult. So just to show you the power of the browser use over here, it's taking a screenshot just as the attack is coming up, just to show that it's indeed only highlighted at the correct frame. And that's how it verifies that it's working correctly. So what I'm going to do now is I'm going to fix the bounds issue. So with the bounds, I noticed that both the attack bounds are low and large in height. Given the weapon's thinness, this should not be so big in height, and it should be positioned higher relative to the bodies. All right, so now let's kick this off so that we can end up with a situation where this gets fixed correctly. So let me just show you the hitboxes here. So you can see the attack boxes are a lot smaller. They are positioned correctly relative to the character as well as the skeleton. So this gives you a chance to evade the attack rather than what we see over here, where the hitbox is just way too big. All right, so you can see it says here that it's going to tighten the attack boxes to match the stick shape better, and then we'll see whether or not this gets it right. Sometimes you might get things wrong, so let's just take a look at how things are right now. So let's just turn it up, and I'm going to pause it. You can see while it's gotten the thinness correct, it's still a little bit too high. So we can pause it and take a screenshot. Okay, and then I wonder whether it's going to be able to figure things out on its own. But while it's running this, we can jumpstart and paste the screenshot here and say the thinness of the attack is correct, but they are still too high relative to the body of the characters. And you can press escape to interrupt in the current processing rather than steering it. You saw the steer button just now, which you can use to let it continue what it's doing and then gently steer it towards an outcome. But in this case, I want to get it to fix this correctly now so that it doesn't waste more time. So the attack boxes are a lot lower now, okay? And this is actually a good size, I think. So you see, I can now evade the attack, and you can spend more time to tweak this boundary. So what you want to do generally is make the collision bounds for your character a little bit smaller than the enemy, so that it's easier for the player to hit the enemy and harder for the enemy to hit the player. Same thing with the attack bounds. You can make it longer so that the player is likely to hit the enemy more than the enemy is to hit the player. You can continue tweaking this as much as you want. For now, let's move on to the next stage where we're going to start to have a health system. So this is not just going to be an infinite running game where you just slap each other. So what we're going to do now is going to use this. So we say, let's make a health system, give them to both the player and the enemies. The enemy's health appears as a health bar, and the player's health appears in the top left-hand corner in a longer bar. And we want this to change color as it depletes, so green, amber, red, and it blinks when it's red. And the player's health is 5, the skeleton health is 3, hit damages 1 always. Okay, so we're just going to kick this off, and the idea is that you will see something like what we see over here, where the health bar is above the enemy, and the player's health is at the top left-hand corner, so it's more evident to the player. And you can see every hit is about 1 damage. So this works well, and I'm going to let the skeleton hit me a couple of times, and you can see it becomes amber, and then it becomes red and blinking when there's only 1 health left. Okay, and that's the end result that we're looking for, because otherwise this game is just an endless battle of just smacking each other silly. So it's now completed the implementation of the health bar and it's running some checks. So let's do our own check within the game. So you can see I've loaded up the game here, and indeed the health bar is showing up above the skeleton, and the character also suffers damage as well. You can see this is very close to the end result that we're looking for. There's just a slight difference in how the health looks, but everything looks correct. It has gone ahead to correctly play the death animation, which is interesting because in my earlier implementation of the game, it didn't automatically implement the death animation for me. In some cases, you will need to prompt the AI to implement the death animation, but in some cases, because it can check things out from the index.json, it will automatically implement the death animation for you. But now what we want to do is that we want to say, on death of the enemy should stay on the ground for a while before blinking and disappearing after a bit. If the player has death, a game over screen appears, allowing restart or back to menu. The game should stop movement animations of any enemies in this case. So that's what we're going to do now, and we're just going to have it such that the game just doesn't reach this strange stage where I can still move my character around and skeleton's standing there. There's no sense that the game is making any progress. What you find is that it's really fun getting these new features in and getting animations in and getting things on the screen. But don't forget to close the loop on the game. You need to have a game over condition, and in some cases, you also need a clear win condition as well. So we're going to let the skeleton hit us a couple of times. Okay. And hopefully we get a game over screen. So not only a progression, but you need to have challenge as well. There you go, game over. So now there's a progression per round. We want to have an overall sense of progression as we go on with the game. What we're going to do now, is you remember in this game, is that each time we defeat the enemies, we clear that round, and then we get a next round where more enemies spawn. Okay? And the way that you want to do this is that you want to have waves of enemies, but you also don't want this to be too random. So let me just show you how to go about doing it. So what we're going to do here is that we're going to use this polling prompt we need to have a game loop with some sense of progression. We should only have a bunch of rounds, and we should progressively increase the number of spawn enemies per round. Only after all enemies are defeated does the round progress, and we should have this progression set up as a configurable parameter. And I'll explain what this means. But effectively, you want to be able to say, okay, round 1 has 2 enemies, round 3 has 5 enemies, and things like that. And I say here, using Fibonacci increments. Don't bother too much about this for now, but you want to have some kind of increment that makes the game more challenging over time rather than just doubling or incrementing by 1. So we will keep track of the enemies killed and time elapsed too, and this gives a timer and a sense of greater progression. We want a progressive fun loop that keeps the player coming back. Easy to learn, progressively harder. So with this prompt, we are going to be able to build a game that has a sense of challenge and progression. On the topic of Fibonacci, this is what you call the Fibonacci sequence. I've come across with whenever I work in games. Whenever you're trying to have some sense of progression, rather than incrementing by 1 each time, sometimes adding this Fibonacci sequence gives you an automatic sense of progression. So you have 1 enemy in the first round, then you have 2 enemies, then you have 3, then you have 5, then you have 8, then you have 13, then you have 21. So it becomes tougher as it goes on. It's not the best, but it's useful whenever you need a non-linear sense of progression. If you don't know about Fibonacci, the way it works is that you do 0, 1. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and that's how the sequence comes about. But don't bother too much about this. This is going to be a big structural change because this is the core game loop, and this is going to take a while longer. Once you reach this point, you're going to be very close to having a complete game. So now let's take a look at whether or not the progression system is running. So we're going to click on sandbox. Oh, you can see round 1 has begun, and you can see that the information around the round is in the top left-hand corner. And let's just defeat this enemy. And then round 1 is cleared, round 2 has begun, and now there are 2 enemies. So it's going to be a lot tougher now, and I'm at least able to evade the skeleton. And let's try this. So you can see these 2. So the next round, you're going to have 3. And it's going to get more and more difficult as things go on. But here you are. You basically have a complete game right now, right? You have a sense of progression. You have a challenge, you have enemies, you have integrated artwork, you have a timer. This is looking really good. So if you've managed to reach to this stage, give yourself a pat on the back because this is further than most people would have gotten. Because they usually reach a stage where they have a couple of things running on screen, but there's no closed loop. And there's just no sense that this is a complete game. Closing the loop is the most important thing when you're building a game. Now, once you reach to this stage, you're going to hit a problem. And if you click on restart right now, you'll see that it doesn't clean up the game properly. Okay, so you get stuck here, your health is down, none of the enemies move, and it's really, really late. Okay, so what you want to do is fix the bug up right now. So you can just say there is a bug, pressing restart does not restart the state, no enemies are spawned, player health is 0. In fact, in this case, enemies from previous session are left behind. Okay, so now we're going to press OK, and what we're going to do is press steer this time, because we want it to continue off where it left off. So it fixed all of these things related to having a progression. But if your restart is not working, then that is a bug. Okay, so steer is like a way for it to continue from where it was at to then implement the fix that you're talking about. Whereas previously, if you remember, I pressed escape. That was just to interrupt it. And that was because I knew for a fact that I wanted it to stop whatever it was doing so that it can fix the bug. So steering your conversation is just another way for you to be able to get to the stage. This is a very common issue whenever you're working with phaser scenes. In 90% of the games that I work with, the restart always encounters issue because there's so much stuff going on within a game session that restarting, needing it to clean up things and put back your health, all of these things tend to get missed. So don't be surprised if you encounter it, and this is the way that you fix it. Just tell the AI that it needs to clean up and restart the state and to clear all the entities that are on the screen. So it says that it's found the root cause, it's going to fix up what's going on over here because it's reusing some existing state. So what it's going to do is that it's going to do a proper cleanup whenever the game needs to restart. And now the restart bug should be fixed. So let's just take a look and get myself beaten up by the skeleton over here. And there we go. And now I'm going to click restart. Now we have things running correctly. This means that we now have a complete loop and we're able to restart the game when we hit the game over conditions. Okay, so that's it. Oh, there we go. And this game's a lot harder now, but now we can restart and everything. So now what we have right here is pretty much a complete game. But one of the things to note is that there's something that's missing, right? The missing thing here is that there's no sound and there's no music. Remember when I told you that when you're building a game, try to focus on making it complete. No game is complete if there's no sound and music. Let me show you a trick to get all of the sound and music into your game without you having to spend too much time looking and searching around for sound effects. So for us to be able to leverage sounds within this game, we can use something called 11 Labs. And what we're going to do is install the 11 Labs skill. The 11 Labs skill basically allows you to generate sound effects, music, and many other things using AI. And the skills allows you to effectively just do everything within your command line or within Codex. And the only thing that you need is an 11 Labs API key. So this is my 11 Labs website. If you go over to the bottom left-hand corner and go to developers and go to API keys, you can actually create a key over here. And then you can just call it whatever you want. All right, I'm going to call this a pirate meet up. And what you want to do is have sound effects and music generation. Only thing you really need. Everything else you can just leave alone. You want to copy this key. And then what you want to do is you want to go into this folder, create an .env file. This is called an environment variable file. You want to call it 11 Labs API key equals to your key here. I'm going to do 11 Labs API key, and then I'm going to copy the key and pop it like that. Okay, so this is the main thing, and this allows you to utilize your 11 Labs account and to generate the sounds that you need. So that's the API key. So the next thing that you want to do is install the skills. So just copy this command that you have over here. And what you want to do is open up the terminal within your project and paste it in here. Just follow the instructions over here. If you need to install their packages, say yes. Okay. And what it's going to say is that it found 8 skills for 11 Labs. What do you need? We just want music. So press space and sound effects. Just press enter. It will already work with Codex and cursor and all this stuff. And usually it will default to having Claude as well. So you just press enter here and then do installation scope to project. And then you can do symlink recommended. And what this means is that rather than having copies of the skills for Claude Code and the others, it will just link both of them together. Just click OK and then proceed with the installation. If you look into your project, you will see that you have a music skill and the sound effects skill. This will also work for Claude, music, and sound effects. If you do $sign and then you do music, you will see that it's pulled it in already, and you can do $sign sound effects. So what you want to do now is use this prompt that we have over here. And is based on the vibes of our game, let's generate BGM or game that matches the theme of pirates on a ship. I guess in this case, it's on a beach, so we can change that. We're going to use the music skill. Also add in sound effects across the board using the sound effects skill. So I'm going to do sound effects. These should be placed in public assets BGM and public assets SFX with assets.json updated. Actually, this should be assets index.json updated. For music, have 4 candidates switchable within the debug panel. So this is just to give you some variation so you can pick. I'm going to kick this off right now. And this, my friends, is like a pro tip. If you need music and sound effects for your game, this is not perfect, but it will get you quite far along the way. What you see here, and I'm going to turn on the music for you now. Everything that you see in this game has been generated using the exact process, using that single prompt. What you saw there was the exact same prompt that I used for that game. And it basically just put in the background music for me and all the sound effects, and I didn't have to do anything more. So let's just see what happens over here. And you will see that sometimes it can't find the 11 Labs API. So he says it's going to check the repo's local.env path. That's exactly why we went ahead and put this in the .env file. So remember that there needs to be a dot in front of it, and then it needs to be named exactly this. So .env. This is just a convention for the system that we're using for loading environment keys. And when you do this, remember never ever to share your keys, because if this key gets leaked, somebody can use your account to generate their sounds and it will deplete your credits. Do not share this. I'm showing it here because I'm going to delete this key once this tutorial is completed. Whatever you have in this .env file, you should never ever share. If you're using Git, make sure that your git ignore has the .env so that this does not get sent into your repository as well. All right, so this is done now. It's gotten all of the 4 different tracks as well as the sound effects for attack, hurt, death, enemy spawn, and all the other stuff. So let's just check it out. Just make sure to go into your settings to make sure mute is off. And let's just see what turns up. All right, so there you have it. That's the music and the sound effects are already integrated. There's some things that you probably want to tweak, but this gets you very far along the way and it makes the game feel a lot more complete. I want to finish off this tutorial by adding some level of polish. If you look at the game that we have over here, this version, you can see there's a little bit of what I like to call juice that makes the game feel more alive. So you can see there's the flashing, there's the screen shake, and it makes the game feel juicier. One of the key things here is that when there's a contact made between the player and the skeleton, the game freezes for a very short period of time, and that makes the impact seem a lot more. I'm going to just continue this conversation that we have over here, and I'm going to say add debug toggles for muting sound and BGM in the debug panel. And so I'm just going to let this continue and implement that because it doesn't have anything else to do with the game. But let's now finally move on to adding the polish that we want. You can see it's already added the shadows underneath the actor, so that's great, so we don't need that. But what we're going to do is that we want to have a noise-based screen shake. So we don't want to have random screen shake. A noise-based screen shake just makes things feel a lot smoother. Minor on enemy hit, but it shakes more when there's a death. We want to have freeze time for the enemy hits, less when it's just a regular hit, and more on death. And then a white flash when the player gets hurt with a cooldown for invulnerability. And then I want it to have some particle effects, and that's all you need to do to make the game feel a little bit more polished. So here we are, and you can see that the game has already implemented the muting, and that allows me to not have this playing while I'm talking over the video as well. Okay, so now you can see compared to what we saw earlier, there's just no screen shake, there's no flashing. So ultimately the game still feels a little bit flat, and these little bits of juice will help to make your game feel a lot more complete. So the polish is completed. So you can see there's just a bit of screen shake. And when the skeleton actually gets killed, you can see that the screen shake goes to become a lot more evident. Okay, and if you actually look very closely, I'm going to just make this a bit bigger. So you can see that there's particle effects now when we hit the skeleton, and you saw that. It feels a lot more impactful, right? So these are the things that you want to do in order to polish up your game, just to make the game feel a lot better. And we can just turn on the music again. I'm going to switch it to this movie. And so there you have it. We have completed this entire game from start to finish. So what started out as a blue square walking around on a black screen, we have now come all the way to this fully integrated game with sound effects, with music, with particle effects, and with all the different levels of polish. It has a full progression loop. It has increasing difficulty of challenges. And all this was done, if you recall, without writing a single line of code. It was all prompted within the Codex application. So I really hope you enjoyed today's tutorial. Don't forget to give it a like, hit that subscribe button, and also turn on notifications so that you always be the first to know when new content like this drops. Now, one thing that we didn't cover in this video is how I went about getting hold of these sprites and animations in the first place. If you want to learn about how all these character animations that you've seen that we've used in the game were created using AI, you'll want to check out this video where I walk through my entire process for generating these animations. So till next time, I'll see you.